Hello everyone, welcome to the presentation of our paper Multivariate Visualization of Game Metrics, an evaluation of Hexbin maps, in which we explore the use of those kinds of maps for the analysis of gameplay data. By now, visualizations have become an important part of games user research and analytics, as well as for players to facilitate the analysis of behavioral data, also including the evaluation of spatial game metrics. A frequent task in this respect is to assess how certain metrics vary across a game map, which is also reflected by the popularity of heat maps in games research. However, one limiting factor of many existing visualizations, and this also includes heat maps, is the focus on a single variable. And this makes it difficult to compare multiple variables against each other and also across a map. Here, we address these issues by using maps based on hexagonal binning combined with visual glyphs to encode multivariate data. As glyph, we use a variation of the so-called Wallner dot. It is basically composed of two circles, where the outer circle indicates the spatial area to which the data belongs to, and an inner circle which shows the actual data within the area. By altering visual attributes, such as the size and color of the inner circle, multiple data values can be encoded. In addition, we also added direction indicators which show directional information, which can also be very interesting in games, for example from where attacks came from. These glyphs have the advantage that they are visually simple and are hence easy to read when they become smaller. The map itself is subdivided into regular hexagons used for binning the data. A glyph representing the data is placed within each hexagon, while the hexagons itself are not shown in the final visualization. Regular hexagonal binning also has several advantages. Amongst others, it creates areas of equal size, which eases comparisons between areas, and it also makes data captured at different time points comparable, as the subdivision itself is not affected by the actual distribution of the data. To evaluate the approach, we used real data from the real-time strategy game StarCraft, showing different information such as the number of destroyed units, team information, or the direction of attacks. Based on the data, we created 5 different variants of Hexbin maps with increasing complexity. The simplest one only showed one variable by varying the size and color of the inner circle. A simple unipolar color gradient was used in this case. The next one also only showed one variable, but used the bipolar color scheme to also include information about the team. This was then further extended by adding a second variable encoded through the color of the outer circle. Next, we added direction indicators to the information already present in the previous map for a total of 3 variables. And the last one, the most complex one, showed 4 variables by encoding 2 variables through the size and color of the inner circle, instead of only one like in the previous maps. For the evaluation, we also defined a number of tasks of varying complexity that the participants had to solve and which captured different aspects of the visualization. These tasks were administered through an online survey, which required participants to mark the correct area on the map. The survey controlled for learning effects by randomizing the order of the maps and also by using different data for them. In total, we received about 200 responses. For each task, we analyzed the correctness, the time taken to solve it, and the efficiency of the visualization for the task. You can find detailed statistics on all 3 aspects in the paper, but today I will rather focus on more high-level implications and results. First, we can say that participants appreciated the display of multiple variables in a single visualization, confirming its value for gameplay analysis. Even with 3 and 4 variables, the visualization remained clean and structured. Correctness achieved with the maps in terms of estimating and comparing values was generally good, but sometimes also reduced by the visual encoding which was used. As such, the visual encoding needs to be chosen with care, as it can severely impact performance. One also needs to keep in mind that only a certain number of variables can be reasonably shown within an area of certain size. Also because the evaluation has shown that the color-coded areas need to be of sufficient size themselves to ensure that the colors can be perceived accurately. To conclude, our results indicate that the display of multiple variables at once, as made possible by the proposed Hexbin maps, is useful for gameplay analysis and that the representation remains clear and structured even for up to 4 variables. If you are interested in a detailed breakdown of performance across the different tasks and maps, please refer to our paper. That's it from me today. Thanks for watching.